Today's assignment is really similar to yesterday's assignment, but no graphing. If you look at the first one, you have a rational expression, and rational just means fraction. It's the fancy math way to say fraction. And it doesn't want you to simplify. All it says is state the excluded values. Which numbers can you not plug in? So for number 1, what are you not allowed to plug in? X is not allowed to be 0. Now it doesn't ask for this, but in this case, is 0 a whole or an asymptote? Why is it a whole? Because that x cancels with one of the x's up on top. Okay. Number 3, we need to factor. Are you guys getting good at factoring without the box? Let's try it. So you can only do this if the leading coefficient is a 1. If the leading coefficient is not 1, you have to use the box. But if it's not, then you can do it this way. Are there factors of negative 21 that add to be 4? M minus 3 and m plus 7. So what are the excluded values? 3 from here and negative 7 from here. Now, just for your information, is 3 a whole or an asymptote? It's an asymptote, it doesn't cancel. Is negative 7 a whole or an asymptote? It's a whole. Now, it doesn't ask for those, but we'll see that again in the future. So those are the excluded values. Okay? That's pretty easy. You can do that. So take a look at number 7. So can I factor without the box in this case? Yes, because the leading coefficient is 1. Are there factors of 8 that add to be 6? So p plus 4 and p plus 2. Does that simplify? The p plus 4 cancels p plus 4, and I'm left with 1 over p plus 2, but I need to state the excluded values. Negative 2 and negative 4. Negative 2 would be what structure on the graph? Negative 2 would be an asymptote, it didn't cancel, and negative 4 would be a whole because it did cancel. What is the difference between this graph and this graph? The big one, the first one has a hole at negative 4, but when you cancel that negative 4, that plugs the hole, and then the graph will be continuous at that point. Okay? So take a look at number 9. Does the top factor? What can I pull out? 2a, and then I have a plus 5. Can I pull anything out of the denominator? 3a and a plus 5. A cancels a plus 5 cancels a plus 5, and I get 2/3. What are the excluded values? Negative 5 and 0, both of which are wholes. Now, what if everything cancels? Then it's 1. It's like saying 2 times 2 times 2 times, let's see if I can do this, 2 times 3 over 2 times 2 times 2 times 2 times 3. That's 144 over 144. So if I cancel all of these, they all turn into 1s, and I get 1 over 1, which is 1. So if everything goes away, the answer is just 1, which may happen on this worksheet. Okay, before we turn to the backside, let's consider something. What if I had 12 over 9 times 15 over 20? If you were to solve this, here's how you don't do it. I'm showing you what not to do. 12 times 15 is 180. And 9 times 20, oh, you're kidding. It's 180. Oops. Whatever. I didn't mean to do that. So Well, it goes into 180 and 180, 1, or 180, so it ends up being 1. Now, before you perform all that multiplication, you can actually factor and cancel as you go. So I can draw a line straight across and turn this into a multiplication that looks like that. 12 over 9 multiplied by 15 over 20 is the same thing as 12 times 15 divided by 9 over 20. Okay? And 12 is 2 times 2 times 3 times 15 is 3 times 5. And down on the bottom, I get 3 times 3 times 2 times 2 times 5. Since I turned it into one big long multiplication, anything on top will cancel anything on bottom. So I can just start 2's, 2's, 3's, 3's, 5's, and everything went away. So let's try this again in a little bit better situation. If I had 15 over 10 times 20 over 35, I could just draw this straight across, and now any factor on top can cancel any factor on bottom. Do you see any that will cancel? I can pull a 5. I can pull a 5 out of here and I get 4, and I pull a 5 out of here and I get 7. I can pull a 5 out of there and I get 3. Pull a 5 out of there and I get 2. Anything else? 2 coming out of there and a 2 coming out of there would put a 2 there. So on top I have 6, and on bottom I have 7. And then you don't have to do 15 times 20 and 10 times 35. Okay? Well, what if it was 12 fifths divided by, let's say, 15 sixths? How do you divide two fractions? You flip and times the second one, not the first one. It's got to be the second one. So I'm going to change this to a multiply, and I'm going to put the 6 here and the 15 here. So I can pull a 3 out of this, so that would be 4. I can pull a 3 out of this, and it would be 5. Nothing else comes out, so 4 times 6 would be 24. 5 times 5 would be 25. We're going to do the same thing with rational expressions on the back side. So take a look. 15 is pretty easy because it's already factored for us. So for 15, it's a divide problem. I'm going to change it to a multiply problem, and I have to invert that. So I get v minus 10 on top. Is there any sense in writing 1 in the denominator? No. Now, any factor on top will cancel any factor on bottom. So the plus 8's go, the minus 10's go, and I'm left with v minus 7. But what are my excluded values? Negative 8 and 10. And that brings up a really good question. So I'm going to take v minus 10, and I'm going to flip it upside down to v minus 10, or 1 over v minus 10, flip it upside down to v minus 10 over 1. So which one do I have to worry about for an excluded value? Do I have to worry about the ones on top originally or the ones on bottom originally? And the answer is both. Will 10 make this fraction undefined? Yes. Can you take this fraction and divide it by an undefined number? Well, you can, because that undefined number is infinity, but dividing by infinity is a problem, so no. Okay? So, if you have dividing by a fraction, this denominator is not allowed to be 0. But when you flip it, then this comes up and that goes down. And if you think about it, let's say 1 is a bad example. Let's say that this was v plus 3. If that equals 0, is that going to be a problem? Why do you say yes, Ty? Because I told you to. Okay, good. So we have a fraction divided by another fraction. But if the top of this fraction is 0, what does the entire fraction equal? 0 over anything is 0. And if you take the first fraction and divide it by 0 over anything, you're dividing by 0. So whenever you have a division like this, the numerator and the denominator both are not allowed to be 0. If the denominator is 0, the second fraction is undefined. All right. Look at, okay, well, 17's easy. I guess we can do 17. So I'm going to put parentheses around that. That allows me to stretch that out. Multiply, multiply. So the x plus 3's go, and the 3's go, and I get x minus 6 over 4, with my excluded value being negative 3. Is that a whole or an asymptote? It's a whole because it canceled. Okay. Let's do 24. Okay. I don't like that. Anybody else not like it? Even if I rewrote it, negative x squared minus 7x plus 8, I still don't like it. Why? It has a negative leading coefficient. Can I fix it? Am I allowed to just times it by negative 1? Well, if I times one side by negative 1, I'd have to multiply the other side by negative 1, and there is no other side, so that won't work. I can factor out a negative 1. So I put a negative 1 outside, and then I'm left with x squared plus 7x minus 8. Does that make sense? Now, are there factors of negative 8 that add to be 7? 8 and negative 1. So the numerator of this first fraction is negative 1 times x plus 8 times x minus 1. And then there's an x plus 8 in the bottom. And on the other side, I have an x plus 5. And does this factor? Pull out a 9, and I'm left with x minus 1. Okay, what cancels? 8's cancel. Negative 1's cancel. So what am I left with? I have a negative 1, which I'm going to distribute back in there. Negative x minus 5 over 9. What are my excluded values? X is not allowed to be negative 8 and 1 and... Don't I have to worry about this one? No, because it's a multiplication problem, not a division problem. If this second fraction were being divided, then you have to worry about the numerator and the denominator. But this one is being multiplied. So that x plus 5 isn't going to ruin anything. Okay? All right. Let's do 25. Does this first numerator factor? X minus 4 and x plus 4 over 9 minus x. Okay, now if you like the box, go ahead and use the box to factor this if you know how to do it otherwise. What multiplies to be negative 90 and adds to be 1? X plus 10 and x minus 9. Okay. What multiplies to be 40 and adds to be 14? X plus 10 and x plus 4. All right, now we start canceling. The plus 4s go, the plus 10s go. Anything else? Ooh, x minus 9 is really, really close to 9 minus x, but not quite the same. Can I mess with it a little bit and make them the same? Change what? We just did this on the last problem. Take out a negative 1. If I pull a negative 1 out of here, I'm left with negative 9 plus x. Is that the same as x minus 9? Yes. So now this cancels that, and I'm left with x minus 4 over negative 1. Well, can I make that a little bit easier to deal with? I can always move the negative out front and change that to a plus 1. And then I don't even need the fraction anymore, but this is in parentheses. Then what? Then put the negative back in, and it would be negative x plus 4. That's the final answer. So every once in a while, you're going to have to factor a negative out and then work it back in depending on where it is and how the problem looks. Okay? All right. Good luck.